Today we're going to be talking about how to factor out the GCF, or the greatest common factor of a given expression. So the first step is going to be to determine the greatest common factor, which we generally abbreviate as the GCF. Okay? The greatest common factor is the largest factor that all the terms have in common. And what a factor is a number that you can multiply to equal the number that we're looking at. Okay, so for example, if we're looking at 33, we know that 3 is a factor of 33 because we can multiply 3 times 11 to equal 33. Okay, so whenever we're looking for the GCF, we want to first focus on the coefficients, and then next look at the variables. Okay, we want to factor out, which is the same as dividing. Okay, the GCF, we're going to put the GCF on the outside of the parentheses. I'm just going to draw some parentheses so we don't have to write that word. And then what is left over after dividing, it goes inside the parentheses. We'll write it out that time. Okay, so we can always check our answer by distributing the GCF back and see if we get the original expression. Okay, so if we come up here to the top, we can see a few of our examples. This first one, 33x minus 6. So what we want to see is, what is the biggest number that we can use to multiply that gives us 33 and 6? Okay, well, we know that 2 goes into 6, right? Well, 2 doesn't go into 33, so we can't use that. Well, we also have 3. 3 goes into 6 and it goes into 33, so that might be a good choice. Now let's say the only other factor of 6 is 6 and 1. So 6 would be maybe a possible GCF if 33 can also divide by 6, which we know it cannot. So that means we're going to have to use 3. So we will place 3 on the outside of our parentheses, and then we are going to divide. 33x divided by 3 is 11x. And then we'll bring down that minus. 6 divided by 3 is 2. Okay, so our GCF is 3, and the leftover expression is 11x minus 2. Okay. This is a trinomial. This one was just a binomial, right? 2 factors. This one, we're going to have a trinomial. We have 3 terms here, so we have to find the biggest number that divides out of all of those. So what I like to do is I always like to go to the smallest number and look at the factors of that number. So in this case, the smallest number would be 14. Okay, the factors of 14 are 1 and 14. Okay, but we can't divide 16 evenly by 14, so we're not going to be able to do that one. Okay, we then are going to look at the next factor, which is 2 and 7, right? So all of these do divide by 2, but they're not all going to divide by 7. And there are no other factors of 14. So that means we're going to have to use 2. Okay, so we're going to place 2 outside of our parentheses. Now we also want to look at our variables and see if there are x's in each term. You can see our first term has an x squared, which means that there is an x times x in there. Our second term has an x also, and our last term does not. If our last term also had an x, we could also divide out an x. Okay, well, it doesn't, so we're just going to use this 2. 48x squared divided by 2 is 24x squared. 16x divided by 2 is 8x. 14 divided by 2 is 7, minus 7. And so that's going to be our final answer. Okay. Down one more, you can see this one has x's in all of the terms. So we know we're going to be able to factor an x out. So since each one has at least an x, we know we're going to have an x on the outside of the parentheses. Okay. Then we look at the smallest number and we see what are the factors of that number, right? The only factors that 3 has is 3 and 1, right? So 3 does divide by each of these. So we're going to factor out a 3x out of each of these terms, okay? So this is a negative, right? Sometimes if every single term is negative, we'll factor out a negative, but in this case, it's just the first two, so we're not going to do that. Okay, so divided by 3x, okay, 24 divided by 3, that'll be -8, and then x to the third divided by x. Remember when we did our exponent rules, we said when we divided that meant that we were subtracting, so that would be 3 minus 1, okay? 3 minus 1 is 2, right? X squared, okay? 6 divided by 3x, 6 divided by 3 is 2. X squared divided by x, that would be 2 minus 1, which would give us 1. And then we have 3x divided by 3x. Anything that's divided by itself is going to end up being 1. Okay, then for another example, you can see here that we have several x's that can be taken out, okay? So since this one is x to the fourth and this one is x squared, we're going to be able to factor an x squared out of both of those factors. Then we want to look at our smallest number, okay? And we know that 81 does divide by 9. So we look at our 9, okay? We have 9 and 1 and 3 times 3, but 9 is going to be the biggest number that goes into each one. So we're going to be able to take out a 9x squared. 81 divided by 9x squared. 81 divided by 9 is 9. X to the fourth divided by x squared. Remember, we subtract. 4 minus 2 is x squared. And then we're going to divide that here. Anything divided by itself is going to be 1. Okay. Then our last example here, we're going to look. This one we cannot take an x out because we don't have an x in every single term, but we are going to be able to factor a number out. So again, we want to look at our smallest number, right? The factors of 10 are 1 and 10, and 2 and 5, okay? So we want to start with 10. Can all of these numbers divide by 10? Well, 100 can and 10 can, but 25 cannot. So we're not going to look at that one. Now let's look at 5, okay? 100 can divide by 5, 10 can divide by 5, and 25 can. So we're going to use that one. All right, so we're going to put our 5 on the outside of our parentheses. Again, since each term doesn't have an x, we can't take an x out. We're going to divide this by 5. We get 20x squared divided by 5, 2x divided by 5 plus 5. Okay. Something that's important to note, when you're completely finished, you should not be able to get any additional things out of here. Like 2 and 5 are both prime and they can't divide by themselves, and 20 can, but we wouldn't be able to divide all 3 by any additional terms.